Welcome to Penn State's High Tunnel Research Facility. In this video, we will show you how to square a site for a high tunnel. Squaring the site is a critical first step in building a high tunnel. If the tunnel is not square, the parts will not install correctly. The two methods we will be explaining here will work for any size single-bay high tunnel. The first approach is commonly known as the 3-4-5 method. It is based on the formula a squared plus b squared equals c squared. The letters signify the lengths of each side of a right triangle. This formula is also known as the Pythagorean theorem. Related to a high tunnel, a and b are the width and length of a tunnel, and c is the diagonal of the tunnel. The 3-4-5 method gets its name because 3 squared plus 4 squared equals 5 squared. In other words, 3 squared equals 9, 4 squared equals 16. Add them up and it equals 25, which is equivalent to 5 squared. This relationship also holds for any multiples of the numbers 3, 4, and 5, but this formula is not limited to just those numbers. Let's apply this method to a 30-foot by 72-foot high tunnel. We'll show two ways to approach this method. Here we have flagged the starting corner of our tunnel. Starting at the flag, we measure 3 feet on the width side and mark it. Again, from the corner, we measure 4 feet on the length side and mark it. The distance between the marks should be 5 feet. Set up strings on the length and width sides that line up with the measured sections. Now you can measure your tunnel dimensions from the starting corner and place the other corner flags. Repeat the process in each of the other corners. When all corners have been checked, the tunnel site should now be squared. As a final check, measure the diagonals and they should be equal. The second approach with this method is to use the tunnel dimensions instead of the 3, 4, 5 numbers. The tunnel is 72 feet long and 30 feet wide. A is 30, and B is 72. First, we square the numbers and then add them together. The final step is to take the square root of that number to give us the length of the diagonal, which is 78 feet. From the starting corner, we measure the width and length of the tunnel. Now, measure from one corner to the other. When all three measurements match the appropriate numbers, the starting corner is now square, and the other corner flags can be placed. Repeat the process for the opposite corner. Once complete, you can then measure both diagonals and they should match. Now, we are going to look at the second method of squaring, called striking an arc. This method is amazingly simple and builds on the same mathematical relationship of a squared plus b squared equals c squared. First, we establish the starting corner. From there, measure the width of the tunnel and place a second flag. We need one side of the tunnel identified for this method to work. In this case, we chose the width. Now, from the starting corner, we measure the length of the tunnel using a measuring tape. Here, instead of marking the corner's location, we strike an arc that is about 5 feet long. This arc can be marked with spray paint or with a powder such as ground limestone, sand, or even flour. Now, move from the starting corner across the width to the other corner. Keep the other end of the measuring tape at the other corner. You will need to calculate the diagonal measurement before proceeding. Use the previous formula to find it. Measure this diagonal and strike an arc. The corner's correct location is at the intersection of these two arcs. Now, flip the measurements and repeat these steps to establish the third side and the location of the remaining corner. Next, check the measurement of the width. If it is not correct, adjustments can be made by repeating the arc steps. As a final check, as done with the 3-4-5 method, measure the diagonals to make sure that they are equal. If they are, your tunnel is square. Now the site is ready for the tunnel to be constructed.